Hey guys, welcome back to our exponential functions unit. So today we're going to be talking about how we graph them. So what is an exponential function, you ask? Well, you could just basically say that it's a function with exponents, right? Wrong. You need to be more specific. So an exponential function is a function in which the variable x is listed as an exponent. And so there is a specific pattern that we follow here. So first off, let's review. If you take a look here at this table, we have 4 different x values with 0, 1, 2, and 3. Now look what happens when we increase the x value by 1. When it's 0, we have 2. When it's 1, we have 4. When it's 2, we have 6. And when it's 2, we have 3, we have 8. So by taking a look at this table, we can say that every time x increases by 1, y increases by 2. That is what we call a linear function. Okay? Now take a look at this table here. There's a little bit of a different pattern. We end up with 0, 1, 2, and 3 is the same x values. But now look at the y values. They seem to be increasing a lot bigger. This is an increase by 4. This is an increase by 8. So this is an increase by 16. This is not a concrete pattern of it with addition. So this is not a linear function. However, notice what we got here. We have 4 and 8. So we multiply this by 2 to get 8. Multiply this by 2 to get to 16, and multiply that by 2 to get 32. And so we have a function right here in which for every increase in x by 1, we have an increase of y by a factor of 2. So every time x increases by 1, y is doubled. That is the concept of an exponential function. And so today we're going to be looking at how we graph these. So I need to pull this up real quick. And here's my big graph here. So an exponential function looks a little something like this. It's a little bit of a curve, and on one end, it seems to be getting closer and closer and closer to a certain y value, but it just never touches it. This is what we call an asymptote. An asymptote is any value of x and y in which a function gets closer and closer to, but never seems to touch or cross. So for exponential functions, it will never go. The graph is always on one side of the asymptote. It never goes on the other side, and it never touches that line. Okay. So if you take a look here, we have 4 times 2 to the power of x. So what can we do here? Well, I'm going to give you a little hint. We are looking at exponential functions in the form of ab to the power of x. And so we have b that is connected to x. It's the base of the power we're looking at. Then we have this a value. So exponential functions are all about plotting points. However, you can get off to a very, very simple start. By plugging a in. This, guys, is your y-intercept. Interesting now, isn't it? Alright, now let's try and graph it. Oh, you don't need to see this. We're going to use y increments of 2, just so you know. Okay? So 4 times 2 to the power of x, we raise 2 to the power of 0, we get 1, and multiply by 4, we get 4. That's why this number right here is our y-intercept. So again, using y increments of 2, we get 4, 0 here. And then we simply go from there. So then we simply plot a few more points. So 2 to the power of negative 1 is 1/2. Multiply that by 4 and you get 2. We're going to do it again. We're going to use negative 2. So 2 to the power of negative 2 is 1/4. Multiply it by 4, you get 1. And then we're going to add a couple. See if we can add a couple more points here. Okay. So 4 to the power of 2. 2 to the power of 1 is 2. Multiply by 4 to get 8. And now we draw our graph. So the big thing to remember about exponential functions is that unless you don't have enough room, test the x values for -2, -1, 0, 1, and 2. Those are going to be your most important points for graphing this function. Okay? So here's our graph of the function right here. As you can see, we have y-intercept of 4 for our a value. And then on the left side, it seems to approach the x-axis. It's getting closer and closer and closer and closer, but it never seems to touch it. So one thing you might want to think about is marking the asymptote. So we're just going to put a dashed line through here. Okay? This is going to be important for when we get to the last two problems, which focus on translations of functions. Alright, that was easy. Now I want you to try this one. Try -2 times 4 to the power of x. See if you notice anything different about this graph when you graph it. Okay? So pause the video and try to graph this yourself. Then come back when you're finished. Okay, so -2 times 4 to the power of x. So we take a look at this function here and identify the a value first. As you can see here, we have -2 as our a value, so that's our y-intercept. I'm just going to mark the point right here. There will be no y increments this time. No big y increments this time. Okay? Now for the rest of the stuff. We get 4 to the power of -1, that's 1/4. Multiply by -2 and you get -1/2. That's a really small value right there. And then 4 to the power of -2 is 1/16. Multiply it by -2 and you get -1/8. So we got some really small values going on here. So I'm just going to graph this part real quick. And then let's see if we can add any more points. So 4 to the power of 1 is 4. Multiply it by -2 and you get -8. And so you get this. Can't reach it, so this is what we got. So notice what the negative number did here. Remember in the first problem I did for you, it was above the x-axis? Well, since we have a negative number as our a value here, we actually just so happened to end up with a reflection over the y-axis. Yes, transformations still exist, not just for linear and absolute value functions, okay? All right, now let's try another one. This one's a little bit different because we actually happen to have a fractional base, and it's less than 1. So we got negative 1/2 to the power negative 1 times 1/2 to the power of x. So notice the negative sign. That really just means we have a y-intercept at -1. Okay. Now let's see what else we can do. I'm going to try -1 real quick. So 1/2 times to the power of -1 is the same thing as 2 to the power of 1, which happens to be 2. Multiplied by -1, remember the negative sign, and you happen to get -2. And then 1/2 to the power of -2 is 2 to the 2 squared, which equals 4. Multiplied by -1, you get -4. All right. And then let's add the positive integers in. So 1/2 to the power of 1, 1/2. Multiplied by -1, you get -1/2. And finally, 1/2 to the power of 2 is 1/4. Multiplied by -1, and you get -1/4. And so this happens to be your graph. So notice what we have in the difference here now. So we've been working with bases that are greater than 1. Now we're dealing with proper fractions here. They're greater than 0, but they are less than 1. Look what happens to the graph. In the two problems that we did, the functions increased this side of the asymptote. Now that we got a fractional base, we end up with a graph that winds up on this side of the asymptote. Okay? Okay? So now those bases are going to be very significant, in which we're going to talk about how they are applied in the real world in the next lesson. Okay? Now, let's see if you can graph another one. So here's your next one. 2 to the power of 1, 2 times 1/4 to the power of x. I want you to pause the video and try to graph. Simple instructions. Okay? Now go on. Take a shot. Okay, so we have 2 to the power times 1/4 to the power of x. We have our a value as 2, so our y-intercept is +2. Finally, we go into the positive land. And then we graph the other points. So 1/4 to the power of -1 is 4. Multiplied by 2, and well, we're headed away from the graph. We're headed away. And then 1/4 to the power of 1 is 1/4. Multiplied by 2 to get 1/2. 1/4 to the power of 2 is 1/16. Multiplied by 2 to get 1/8. pretty tight to the asymptote here. Alright. Now let's try something more advanced. We're now going to be looking at functions in this form. We have ab to the power of x. Now we're going to add an h and k. So you know what this means? Well, if you remember back in linear and absolute value functions, we have the h value as a translation of this part ab to the power of x, and then we have our k value, which is a vertical translation, which also raises our asymptote up or down. Okay? So now let's try to take a look at how this works. So we have 4 times 2 to the power of x. That's going to be our main portion. Coincidentally, this just so happens to be a function that we've already graphed with a few translations. So we're going to graph that function, that parent function first. I'm going to draw it in pencil because it's not the function that we're trying to graph. So let's see if we try to graph this again. Y-intercept is 4, 2 to the power negative 1 is 1/2, and it's 1/2, multiply by 4 to get 2 actually. Two to the power negative 2 is 1/4, multiply by 4 to get 1, and then those are the points we can graph, okay? Points we can graph, okay? Now let's try to graph this within translations. So you have x equal to 3. Remember, it's a subtraction sign, but it's still a subtraction sign like we see here. This h value right here is the horizontal translation. If this were a plus sign, we'd be translating to the left. However, we're translating to the right. And then we raise those points up 2 units. So we unfortunately cannot do that with this y-intercept here. However, we can shift these 2 points over. So it's going to be 1, 2, 3, and 1, 2. So I'm going to mark this point here with the actual pen, and then 3 units to the right for this point is 1, 2, 3, and then we go up, and then we go up 1, 2. 2. And so there's our graph there. Graph there. And then, because of the vertical translation, we have to draw our asymptote so we can graph this easily. So our asymptote happens to be at y equals 2 because the k value was x equals 2. And now we graph. Pretty wonky because of how narrow we had this graph, okay? So I'm sorry for the inconvenience. But don't worry, we gotta clear this out. Alright, I'm gonna make you graph one more. So try this one. F of x equals negative 2 times 3 to the power of x plus 2 minus 1. Okay, so I want you to pause the video and then try to graph this yourself. Remember the rules remember, graph the main part first, which is negative 2 times 3 to the power of x, then shift that graph the number of units are supposed to move it, okay? So pause the video, graph it, come back when you're ready. Okay, so we're going to start with the regular function, with the parent function, negative 2 times 3 to the power of x. So, as you can see, we have our a value as negative 2, so that's our y-intercept. So After the parent function, not the regular function, the parent function. Okay, stop restoring me messages, sorry. And then we graph. So let's start with -1. So 3 to the power of -1 is 1/3. Multiplied by -2 is -2/3. And then 3 to the power of -2 is 1/9. Multiplied by -2 to get -2/9. And then 3 to the power of 1 is 3. Multiplied by -2 to get -6. So I'm going to try to graph up beyond the graph, to get this beyond the graph. All right. And now okay, so now that we got the parent function down, we're going to translate. So we're going to shift every single point that we just plotted 2 units to the left because it's a plus sign, and then 1 unit down here because it's a subtraction sign. 2 units left, 1 unit down. Let's try to remember that. And then so we're just going to do this, and then some of this. Man, this is a nasty one to graph. So we're going to draw our asymptote at y equals -1 because that's our k value. It's -1. And then we're just going to try to plot these points. Alright, so that's it, guys. That's how we graph exponential functions. Okay? Congratulations. So next time we're going to be talking about exponential growth and decay and how all that relates to the real world. So we won't be talking a lot about reflections today, like we have in here. Half of our functions had to deal with reflections over the x-axis. So we're not going to be talking about that much next time, but we're just going to be looking at positive a values, okay? Anyways, thank you so much for watching today, guys. Be sure to leave a like and subscribe and tell your friends about the videos. And hopefully you have this content down and you're ready to roll. Okay? So thank you so much for watching, guys. Have a good rest of your day. So long, folks.